In this video, we're looking at linearity and direct proportionality. So this topic will come up a lot, especially in subjects like physics, and it is pretty much what it sounds like. So a graph is linear if it looks like a straight line. Great definition. So all these are linear, all these are not linear, for example. And we'll look at tables of numbers eventually, but for now, all we need to know is a straight line. In terms of direct proportionality, it's directly proportional if it's a straight line and it goes through the origin. So you can look at these functions up here and none of these are directly proportional, even though they're linear. Now, if you did have one that went through the origin, like that line there, then it would be directly proportional. So you got to be a bit careful with that. Okay, so let's do a few questions here. Is this linear and is it directly proportional? Well, linear, the answer is yes, because it's a straight line. And directly proportional, yes, because it's linear and it goes through the origin. So it goes through the origin here, it's that point 0, 0, and it's a straight line. It has to do both those things to be directly proportional. All right, next one, is this linear and is this directly proportional? So the answer is a yes, it is linear, but no, it is not directly proportional because it doesn't go through the origin. This one here, well, it's not linear. And as soon as we know it's not linear, we know it's not directly proportional. Now this one's a bit tricky because no, it's not linear because it is not a straight line. And it does go through the origin, but it is not directly proportional because to be directly proportional, you have to go through the origin and be in a straight line. This one here, yes, it is a straight line, but no, it does not go through the origin. So that's how this works. Okay, with tables, basically what you need to do to prove that it's linear is just check, does it go up by the same amount each time? So this little bit here, see how x is going up by 1, y is always going up by 2 in that step. But here, when x is going up by 3, y is changing how much it goes up by each time. So that one would be linear and that one would not be linear. With directly proportional, you have to look at dividing the two numbers in the table each time you find numbers, and then see if you get the same number each time. Well, I'll show you what that looks like. So first things first, is this graph linear? Well, let's see. I'm going to be adding 1, and I think I'm going to be adding 1 each time. So that's great. Here, I'm going to be adding 2. Am I adding 2 again? Yes, I am. What about now? Yes, I am. What about now? Yes, I am. So is this linear? Well, the answer is yes. So yes, because we go up by the same amount each time. Now, is it directly proportional? So to do the test for directly proportional, you have to divide your two numbers. So 5 divided by 1 equals 5. Great. 7 divided by 2, uh-oh. Well, let's see. I think that is about 3.5. And we are very sad because those two numbers are different. If this was directly proportional, it would be like 5, 5, 5, 5, 5 every time we do this. So directly proportional, the answer is unfortunately no, because we get different numbers when we divide our x and y values. Not directly proportional. Here we go. Is this linear? Well, let's check. Plus 1, plus 1, plus 1, plus 1, plus 3, plus 3, plus 3, and plus 3. This indeed is linear because it goes up by the same amount each time. So yes. Now let's look at what happens when we divide the two numbers. All right, 3 divided by 1 equals 3. 6 divided by 2 equals 3. 9 divided by 3 equals 3. We're on the right track. 12 divided by 4 equals 3. And 15 divided by 5 equals 3. Great. So is it directly proportional? Yes, because y divided by x always gives the same answer. Now, one little note. If it's linear, it's going to look like the straight line graphs we've seen already. That is y equals mx plus c. and that is for linear. Now, if it's directly proportional, the graph looks pretty much exactly the same. You just don't have the plus c bit on the end. Important to note that. All right, let's keep going. So, more tables. Here we go, 1, 2, 3, 4, 5, and then it's going up by 1 each time. And it looks like this is probably linear. Yep, go up by 1, go up by 1, go up by 1. So yes, no. How do I know that it's not? 4 divided by 1 gives me 4. 5 divided by 2 does not give me 4. Here we go, there's another one. Linear and directly proportional. So is it linear? Well, plus 1, plus 1, plus 2, plus 1. Let's see. Plus 5, plus 5, plus 10, plus 5. Now this looks a bit weird, but it's actually all good because I went up by, when I go up by 1, I go up by 5. And if I go up by 2, so if I double it, I go up by 10, which is doubling it. So this still is linear. And you can kind of imagine if I had the point where x equals 3, y would probably be 15 in the middle there. Is this directly proportional? Well, this doesn't really work for our division test, but we know directly proportional has to go through the origin. So actually, we already know that it is directly proportional, but let's just check. 5 divided by 1 gives 5, yep. 10 divided by 2 gives 5, 20 divided by 4 gives 5, and 25 divided by 5 gives 5. It is directly proportional. Cool. So we haven't seen an example of a non-linear graph yet, but you can kind of imagine if that was like a 26 or something, it would have gone up by 6, and then it would not have been linear in that case.